Alright, so in this video we're going to be talking about inverse functions, but before we can really talk about inverse functions, we got to first talk about what a function is, right? So I have drawn two little ovals. The left-hand side is the domain, and the right-hand side is the range. So what is the domain and what is the range? Well, as far as we're concerned right now, the domain is just a collection of numbers. As we can see in our domain right now, we have the numbers 1, 2, and 3. And the range is also some other collection of numbers. So in our range, we have numbers 11, 8, and 5. So what does a function do? Well, a function, what it does is it takes numbers from our domain and maps it to some number in our range. So for instance, if my function look like this. Let me zoom out just a hair. If my function was f of x plus 2, then if I plug in 1 into this function, I'm going to spit out, well, my function will spit out a 5. That means 1 will be mapped, this is going to look ugly, but 1 will be mapped to number 5. Okay, well, what if I put 2 into this function? Well, if I put 2 into this function, I get out an 8. So that means 2 will be mapped to 8. All right, in the same manner, if I put 3 into this function, I get out an 11. So if I put 3 into a function, it gets mapped to the number 11. So what does the inverse function do then? Well, the inverse function, the function takes things from our domain and maps it to things in the range. The inverse function, what it does, it takes things from our range and maps it back to the original number in the domain. So you'll see the inverse function, it's usually denoted like this with f and a -1 up here. And some instructors give it an input of y, and some instructors put it as in terms of x. So it's really up to them. But the general concept is this. It takes an element from the range and it maps it back to some element in the domain. So for example, if I take the inverse function of the example we were just looking at, if I take this number 11 right here and I put it into its inverse function, what it's going to do is, if I put 11 into its inverse function, I get out a 3. So what's happening is it's taking 11 and it's mapping it to 3. Okay, well, if I put 8 into my inverse function, it spits out a 2. That means it's taking this 8 and it's mapping it back to 2. And lastly, if I put 5 into this inverse function, it spits out a 1. So guess what? 5, it gets mapped back to 1. So as you can see, a regular function takes the elements from the domain to the range, or it moves from left to right. But the inverse function, what it does is it takes elements from the range and sends it back to the domain. So it goes right to left. So you're pretty much, you're just kind of going in a circle here. Okay, so one other thing I'm going to say though is if you were to map a function and then map its inverse, what you'll see is that there's some sort of flip over the y equals x, not axis, but line. So for instance, let's see which one's which. So this black line right here, this black line is our function f of x equals whatever it was here. I can't even remember, 3x plus 2. And this red line here is our inverse function. And what's happening is when you graph the inverse function and the function on the same grid, you'll see that it's a flip over this blue line, which is y equals x. So if you look at it the right way, you'll see that if you flip this black line over this blue line, you'll get to this red line if you were like rotate it around this blue line. So that's another thing about inverse functions. When you graph them, it should be a reflection over the y equals x line. Okay, so how do we go about finding inverses? We know the concept behind them. So given a problem like this, find the inverse of f of x equals 4x plus 1. How do we go ahead and find the inverse? Well, I broke it down to 4 steps, all right? The first step is this. Let's change f of x into y. So wherever you see f of x in the above statement, just change it to y. So we're left with y equals 4x plus 1. The next thing you want to do is you want to switch your variables. Let's change y to x and x to y. So you can switch your variables to switch your x and y variables. There are different ways to do this, but this is how most instructors teach their kids on how to find inverses. So I'm assuming this is going to be helpful to the majority. All right, lastly, well, second to last, what we got to do is we got to isolate the y variable. So we have to do a bunch of algebra. Well, in this one, it's only 2 steps. First thing I'm going to do is I'm going to subtract 1 from both sides. If I subtract 1 from both sides, I'm left with x minus 1 equals 4y. Good. So one more step. I got to get this y by itself, right? That's my whole goal. So I'm going to divide both sides by 4. So what am I left with? X minus 1 divided by 4 is equal to y. So I told you there were 4 steps. Step 1, step 2, step 3. Here's the last step. The last step is easy. Just change y to f inverse of x. I'm showing you that if 4x plus 1, if his name is f, the inverse is called f to the minus 1. All right? So I'm using this notation just to show you guys that this is the actual inverse of my original function. And I do that just by putting this minus 1 at the top. So this is our answer. We have x minus 1 divided by 4 equals f inverse of x. Okay, so if you graph both of this, let me see this real quick. Okay, good. So this green line was our original function. This green line that you'll see is the original function. And this purple line is the inverse of it. So again, you can see that to get from the green line to the purple line, you got to kind of do a flip over this y equals x axis, if you want to think about it. If you flip it over this blue line, you'll get to the purple line. All right, great. So let's do another one. All right, so here we are. Find the inverse of f of x equals 3x plus 2 to the third power minus 1. So again, we're going to follow the same 4 steps. The first step, change f of x to y. So my equation reads y equals 3x plus 2 cubed minus 1. Second step, I'm going to switch my variables again. Switch y and x. So I'm left with this whole mess right here. X equals 3y plus 2 cubed minus 1. All right, now it's algebra time. Now we have to isolate y, get y by itself. So the first thing I'll probably do is add 1 to both sides. So if I add 1 to both sides, I get x plus 1 equals 3y plus 2 cubed. Okay, so I want to get y by itself here, but the problem is it's stuck, right? It's trapped because of this exponent. So I have to get rid of this exponent. If I have an exponent of 3, in order for me to get rid of it, I have to multiply it by 1 over 3. So what I'm going to do is I'm going to raise both sides of my equation to 1 over 3. See, if I raise both sides by 1 over 3, then on the right-hand exponent, I get 3 divided by 3, which is just 1. So if I have 3y plus 2 to the first power, that means it's the same as saying that there's no exponent at all, right? So like I said, I'm going to raise both sides to the 1/3 power. So on the left-hand side, I have x plus 1 to the 1 over 3. And then on the right-hand side, my exponents ended up canceling out, and I got 3y plus 2. Okay, so I'm almost there. I almost have y by itself. I just got to get rid of that 2 and that 3. But before I do that, what I'm going to do, it's an optional step. You can rewrite this guy, 1 over 3 exponent, as cube root. So that's just an optional step. You don't have to do that. But if you want to, go for it. So you have the cube root of x plus 1 equals 3y plus 2. Now let's keep isolating that y. I subtract 2 from both sides, and I divide both sides by 3. And now you finally have y isolated. Remember step 4? Step 4 is changing y to indicate that it's the inverse of our original function f. So all I got to do is now switch y to f inverse of x. And there we go. And let's take a look at its graph. So this purple line is our original function, and this red line is our inverse function. So notice, if I flip that purple line around, if I rotate it around that blue line, I get to that red line. So you always want to think, the inverse function, to get to the inverse function, always flip your graph over the y equals x axis, or y equals x line. I don't know why I keep saying axis. Okay, one more. So find the inverse of f of x equals x squared plus 1. So step 1, change f of x to y. Great, we did that. So we have y equals x squared plus 1. Step 2, switch your variables around. I think you guys are getting the hang of the steps now. So we have x equals y squared plus 1. And now our goal is to isolate y. First thing I'm going to do is I'm going to get rid of that 1. If I subtract 1 from both sides, I can get rid of that 1 on the right-hand side. So I get x minus 1 equals y squared. So you guys can see, let me zoom that out. Good. X minus 1 equals y squared. Now again, what we have is we have a y stuck underneath an exponent. We got to get rid of this square right here. So how do we undo a square? We take the square root. Now always be careful when you take the square root of a square. Whenever you take the square root of a square, this magical x and plus, this plus or minus always pops up on the other side. Okay, so anytime you take the square root of a square, this plus or minus pops up on the other side. So what does that plus or minus really mean? Well, it means that y is split up into two cases. Case 1 is where you only consider the plus sign. So you write this. So you write y equals plus square root of x minus 1. Case 2 is where you consider the negative case, meaning you consider this negative sign only, not the positive sign. So you'll have y equals minus square root of x minus 1. You see, so this plus or minus produces two different cases. One where you think about the plus sign, the second one where you think about the negative sign. So this is cause for concern here. Why? Because this is saying for my function, if I plug in some number for x, I have to consider both of these cases. So for instance, if I put 10 into my function, I get two cases. One where 10 minus 1, sorry, wrong pen. If I put 10 in for x, I get 10 minus 1 under the square root, which is 9, the square root of 9, which equals 3. And the same thing comes down here. I have 10 minus 1, which is 9. Square root of 9 is 3, right? This whole thing is equal to 3. But there's a minus here on the outside. So what am I trying to get at here? I'm saying that if you plug in 10 into this function, it's going to spit out two outputs. The first output will be 3, and the second output will be minus 3. Now, if you do that for every single number in the domain, you'll get something that looks like this. See, this blue line is our original function, a parabola, that's translated 1 unit up. And this guy is the potential inverse function, this red one, this red graph. But in order for something to be a function, it has to pass what we call the vertical line test. You see this, this green vertical line going down? The vertical line test says that if you draw a vertical line down your graph and it hits your graph in more than one spot, just like it does here, then what you're trying to graph is actually not a function at all. So because our red function, our inverse function, does not pass the vertical line test, it's not a function. So what we say here is that this function, x squared plus 1, does not have an inverse function. Why does it not have an inverse function? Because it fails the vertical line test. Because if you plug in one x value, it produces 2 different y values. So therefore, this function does not have an inverse.